Greetings! This is your co-host Dan Green, and this video inaugurates our first news video for our new YouTube channel devoted to comets and their solar system cousins. This video has been a team effort with co-hosts Carl Hergenrother and Charles Morris. First, I'll outline some of what we feel are among the more interesting news stories concerning comets in the last several months, and then Carl will discuss one very intriguing comet that will be in the news for years to come. We use the standard IAU designation scheme for comets, which is outlined here for those who might be unfamiliar with how comets are referred to. As comets are named for their discoverers, and many comets thus contain the same name, it is important to use their designations to refer to them unambiguously. We'll start with an object that is a most unusual comet, the Apollo-type minor planet 65803 Didymos, whose orbiting natural satellite Dimorphos was intentionally hit in late September by a NASA probe called DART, in order to see what effects on its orbit might occur from such a planned impact. The impact blew a huge amount of rocky, dusty material from Dimorphos into the surrounding space, and the resulting tail of material has been observed from Earth-based telescopes ever since. Astronomers will be following this minor planet eagerly over the coming months to see how long the tail continues to be visible. Comets are distinguished from asteroidal minor planets by their showing a coma and/or a tail, and in this case we have our first example of a comet created by mankind. We have not had any bright comets yet in 2022, but Comet 2022 E3 may reach total visual magnitude 6 in February 2023, possibly dimly visible to the naked eye from dark skies for eagle-eyed observers who know where to look. It should be easily visible on binoculars in January and February. We have seen the announcement of about 30 new comets since June, together with a handful of recoveries, some planned, some accidental, of previously known short-period comets that had only been seen at one apparition or return to perihelion. The leader in new comet discoveries continues to be the Pan-STARRS program in Hawaii, followed by the University of Arizona program using telescopes in southern Arizona. One known comet, 285P Linear, had a large outburst of perhaps as much as 4 or 5 magnitudes in late July, but it remained a faint telescopic comet throughout. Perhaps the best observed comet this year has been 2017 K2, which has reached total visual magnitude 8 to 9 and been observed with binoculars in recent weeks. Every year or two now, we seem to get at least one comet that is seen to split or have multiple nuclear components, and this year a comet known for splitting a lot in the past has shown a couple more pieces, Comet 73P. Many comets appear first as asteroidal before they are later found to show cometary activity, sometimes very little activity that is only observable with large telescopes, especially for comets that remain faint. Sometimes these objects get minor planet designations first, which are then switched to comet designations with a prefix C/ or P/. Some comets are found belatedly and are able to be announced as comets because other surveys obtain so many images that can be looked at closely later, with the aid of orbital elements to find previously unknown observations, further refining orbits and even allowing for cometary activity to be found. Much detective work goes into piecing together enough observations to be able to announce a new comet. Some of it by archival specialists working with large professional programs, such as Rob Work with the Pan-STARRS program, and some of it by amateur astronomers looking at archival data that are publicly available. Sam Dean is one of their preeminent amateur sleuths, currently poring over publicly available images from professional observatories and finding gold in the way of new comets. Mike Meyer is another such expert sleuth who sifts through archival photographs to find lurking comets that were previously unlinked to known comets with good orbits. Sometimes amateur astronomers like Meyer and Dean work separately but end up having their work support each other on single comets. Suichi Nakano is another expert sleuth who sifts through publicly available and previously published positional observations of objects to produce much longer orbital arcs. Nakano is perhaps the most experienced and knowledgeable computer of cometary orbits alive today. This particular example is unusual because it involved the renaming of a new comet based on observations that Nakano identified from 22 years ago. These amateur sleuths find comets in the most intriguing of publicly available places. One here starting with the discovery of a solar system object by the TESS satellite that was looking for new exoplanets far from our own solar system. Edwin Schwab is one of several amateur astronomers who regularly searches for the first observations of returning short-period comets from predictions based on their first and only observed previous return, that is, its discovery apparition. Again, with team efforts abounding, people like Nakano often step in to find additional past observations to make the orbit even more secure. For up-to-the-minute news and images and observations of comets, two of the best sources are the ICQ Comet Observations Facebook page, which is a publicly accessible page where expert observers post their observations of all comets, bright and faint, and the publications of the Central Bureau for Astronomical Telegrams, most prolifically those known as CBETs and often cited here in this news video. We plan to produce these news videos here at least bi-monthly, but even sooner when there is very interesting news about comets and their cousins. And next month we plan to produce an alternating month video containing interviews with well-known comet experts. But now I'll turn to Carl, who will discuss a most fascinating and unique comet that will be in the news for years to come.
From time to time, we'd like to talk about some recent comet-related science publications. Today we will highlight some articles published about one of the most interesting comets to have ever been discovered. We're talking about Comet C 2014 UN 271 Bernardinelli-Bernstein. Comet Bernardinelli-Bernstein was discovered by Pedro Bernardinelli and Gary Bernstein, both at the University of Pennsylvania. What sets this comet apart from the others is its distance from the Sun at discovery, its brightness while so far out, and presumably its large size. The comet was discovered in data collected as part of the Dark Energy Survey, which uses the Dark Energy Camera, or DECCAM, on the Blanco 4-meter telescope on Cerro Tololo in Chile. The Dark Energy Survey is focused on measuring the distribution of dark energy in the universe by observing supernovae and gravitational lenses, among other members of the cosmological zoo. It was not primarily looking for solar system objects. But just because the Dark Energy Survey wasn't looking for solar system objects doesn't mean they weren't being recorded. And this is why Pedro and Gary were using the Dark Energy Survey data to look for slow-moving trans-Neptunian objects. Specifically, they were looking for very slow objects at distances of 29 AU from the Sun or greater. Luckily, Comet Bernardinelli-Bernstein was just far enough away to have been picked up by their search. Though not announced till 2021, the discovery of Bernardinelli-Bernstein happened in data taken back in 2014, when the comet was 29 AU from the Sun, right around that innermost distance that Bernardinelli and Bernstein were looking for new TNOs. To put things in comparison, 29 AU is the distance to Neptune. As of the time of this recording, in late 2022, the comet is now 18 AU from the Sun, about the distance to Uranus. When it finally arrives at perihelion in January 2031, it will be at a distance of 10.9 AU from the Sun, or just outside the distance of Saturn. There are a few methods that can be used to measure the size of a comet's nucleus. Short of visiting this object with a spacecraft or directly measuring its size during stellar occultations, the best method is to measure its brightness at visual wavelengths, where we are measuring the amount of light being reflected by the comet, and at infrared to submillimeter wavelengths, where we measure how warm the comet's surface is. Two groups have recently published results, one from ALMA, the Atacama Large Millimeter Array, and the other using data from the Hubble Space Telescope. Emmanuel Lelouch led a French and Spanish team that measured a large diameter of 137 kilometers with the ALMA data, and a red geometric albedo of 5.3%. Mantu Hui led a team from China, UCLA, and the Space Telescope Science Institute, and achieved a similar result with their observations based on data from the Hubble Space Telescope. In this case, they were able to model the comet's dust coma and subtract it from their images, only leaving the flux of the nucleus to be measured. Their result was a little smaller than the one derived from the ALMA data, but still found a large nucleus on the order of 120 kilometers in diameter. That by combining the Hubble and ALMA results, they came up with a typically dark albedo of 3.3 to 4.4%, which agrees fairly well with the ALMA only value of 5.3%. These results place 2014 UN-271 as the largest Oort cloud comet ever found, and second only to the Centaur 95P Chiron as the largest known active comet in the solar system. Since we still have 8 years until Bernardinelli-Bernstein reaches perihelion, we will be hearing a lot more about this comet for many, many years to come.